Evening, folks. Brian here, Geomagnetic Earth Watch on. Let's see if I can get the date right this time. Monday, April 29, 2024. Hope you're all well. We're going to have a talk. Please, no. No standing ovations. Okay, please sit down. Thank you very much. He doesn't like boasters, braggers, and people full of pride. Okay, he scorns at those kind of people. And boy, there's going to be a lot of people who got some answers pretty soon. Arnold, you in class? Arnold? Okay, there you are. Arnold's a flatlander, Alberta, on the other side of the Rocky Mountains for me. He's always first on my YouTube channels, videos. Hi, Arnold. Okay. We're going to talk about the effects of cosmic rays on our planet, specifically our volcanoes. So I'm going to start off by saying that cosmic rays are going to become more key in forecasting volcanic eruptions. And this is based on a study by two Japanese scientists studying the Sakurajima volcano, whereby they placed some detectors inside the volcano to detect the muons, to map the inside of the volcano. Now, normally eruption forecasting is based on gas emissions, deformation, surface deformation, inflation, seismic activity, and of course, heat detections. Now, when we're talking about cosmic rays are continually bombarding our planet. More so during, say, coronal hole stream openings, impacts by coronal mass ejections, CMEs, M from Sal, which can accelerate and actually penetrate through the crust. Actually, before they do, I need to stop. So when a cosmic rays comes in contact with the atmospheric atoms, a secondary change takes place. The cosmic rays, when they interact with the atmospheric atoms, they decay and result in secondary showering particles we call muons. Muons, which are more denser and can penetrate through Earth's crust right down into the outer core of our planet, and for the purpose of this talk, into the volcanoes, the magma chambers. Again, this is a case study done by two Japanese scientists, but I'm going to be expanding on it. So accurate volcanic potential forecast does not rely on a single parameter or timing, but other factors need to be considered when we think about when a volcano might erupt. So if a volcano like Campiflegra or even Vesuvius starts having earthquakes, you know what? It could be tomorrow, it could be 10 years, it could be 50 years yet before anything happens. I'll give you two examples. Honga Tonga Honga Haipe, that exploded in January 15th, 2022. I was watching that for 12 months, specifically watching the heat build up. However, La Palma, I was watching it for only 30 days. The heat building up before it went off. Neither one, well, maybe Honga. The Tonga region is always, almost every single day having deep earthquakes. So the timing, you know what? You don't know. There is one very interesting point we need to consider. And that is a drop in barometric pressure can weaken the protection over that area, allowing even more cosmic ray penetrations. Case in point, the June 1991 Pinatubo eruption happened immediately after or during a typhoon, I'm going to spell it, Yunya, however you pronounce it, which is a tropical cyclone. So this is going to be a very key factor in determining an increase in volcanic eruptions is during storms, cyclones, typhoons, when the barometric pressure is like an envelope over an envelope, is like an umbrella over an area which provides some protection from the showering particles. However, during stormy weather, that umbrella is going to fold in, leaving that area more exposed to increased penetration into the volcanic chambers of muons. And again, case in point was the 1991 Pinatubo eruption. So here's the thing, folks. Now, there's one thing I'm going to point out, and I've seen this on a regular basis now. As you know, I watch global heat patterns and heat detections. Almost every single case, almost, these heat patterns start showing up as that part of the planet rotates into the sun-facing side solar winds. So starting anywhere around 10:30, that's when everything starts up. Because the sun rotates, the Earth rotates into the sun, into the solar wind streams. This suggests that our protective magnetic field is a lot weaker than we think. Just two examples. It's the Bahamas, that I show you on a daily basis now. Another example is, I've never shown you this before, I've been watching it for years. The Sutter Buttes by Yuba City, north of Sacramento. When I used to use NextLab satellite and radar, soon as California or the United States rotates into the sun, you see all the flare-ups, all the heat signatures start popping up all around Sutter Buttes. It's the cosmic winds penetrating through the crust, pulling up the magma. So unfortunately, we don't know how weak our magnetic field lines are. The last World Magnetic Model Field Intensity Map was issued in 2019. It's done at 5-year intervals. It was supposed to be done in 2020. However, in 2019, magnetic north decided to really pick up in speed. It caught everybody off guard. So they had to rush to do an updated version. In 2019, end of 2018 into 2019 was the U.S. government shutdown. Do you want to know why? Because they had to frantically reset all the GPS systems, and I suspect the guidance systems on the ICBMs, etc. You think? The World Magnetic Model Field Intensity Map. I'm not talking about the declination map, which has been issued. It's got nothing to do with it. I'm talking about the intensity, showing where the weak areas on our planet are on our magnetic field. Folks, we're never going to see that again because it's not good. So aside from the Aurora Borealis, the northern lights getting further and further south, I'm telling you, watch for the rise in heat and increase in volcanic eruptions. So here's our situation, folks. We have the perturber coming in, affecting all the planets. I'm talking about Sal. For those of you who don't know or have forgotten, the name of our primary sun, that which we see and gives us heat and light, is Sol, S-O-L. It has a companion, a binary. I just gave it the name Sal instead of saying planet all the time, so. And clearly, if you know your scripture, you know that Sal will become, or is, a wormwood. And everything's just matching up perfectly into the timeline. So my theory has been for more than 2 years now, that because of the outer core expansion, so the cosmic rays, or the muons, or the highly charged particles, get funneled down into the north magnetic cusp and go all the way down into the outer core of our planet. The outer core of our planet is where the magnetic field is generated from. When those highly charged particles comes in, it's going to inflate the outer core. Like that. And as we have more and more charged particles coming in, it's going to inflate even more. Where's that pressure in magma going to go? It's going to go up through the mantle plumes, which are anchored to the outer core. Something that Ben Davidson said doesn't exist. Well, he's a spook, so it doesn't matter what he says. So that pressure that rises of the magma, it's going to be detected in order of the thickness of the crust, starting with the thinnest of the crust, the oceanic plates, on average of 6 to 8 kilometers thick. Then I said, we're going to start seeing indications along the continental shelves, which is the next thickness of crust. Then we're going to start seeing heat indications along the coastlines. And finally, further inland. I suggested 16 months ago a mantle plume or a super plume below Australia and the surrounding area. Fiji, Solomons, Bismarck Sea, Indonesia. I said back then that if this is true, and as the outer core continues to expand, I surmised that you're going to start seeing earthquakes starting around the perimeter of Australia. And heat. I would say watch very closely, continue to watch closely. The perimeter of Australia, Tasmania, Timor Sea. I find it very unusual that little tiny island, the 9th island, just off the coast of Tasmania, is increasing to heat up. It's starting to show more and more heat detections. So here's the situation, folks. Remember what I said about a drop in barometric pressure. The outer core is expanding, it's heating up. The ocean's waters are heating up. You heat up the ocean waters from below. And then because of the complete breakdown of our jet streams, bringing down the colder air from the polar regions, you bring those two together. And this is why they are telling you now they have to have a Category 6 classification hurricanes. A great many more tornadoes, more destructive weather events, cyclones, typhoons. More storms, more drop in the barometric pressure, more increased penetration of the muons into volcanic areas. Starting the coastline, such as I've been showing you in New Jersey, New York, Carolinas, Florida, Bahamas, the northern coast of South America, Central America, off the coast of LA, San Francisco, Puget Sound into Seattle, and now my former area, Vancouver, and surrounding regions, all around the entire perimeter of North America. It's boom time, kids. Acts 2, verse 19. Signs on the earth below, blood and fire and billows of smoke. You can apply all that is written in Scripture to things that are happening now and that will happen. So it's not just our storms that we have to be concerned about. Yes, it's sorry that so many volcanoes have blasted into the United States. Ruang volcano, north of Sulawesi. It's not going to be just one major volcanic eruption somewhere. It's going to be many. And fires. Yeah, we're going to have water events, such as Luke 21, verse 25. Nations falling into anguish and perplexity at the roaring and the tossing of the seas. The roaring and the tossing of the seas is the heating up of the oceans, creating all these destructive weather events. The weakened protective magnetic field is allowing more and more of the muons to get into our volcanoes. Now, normally, during increased solar winds, coronal mass ejection events, solar radiation storms, the magnetic field lines return back through the north polar cusp, back down into that outer core. It's an energy absorption. Increasing. And if we don't have enough earthquakes and volcanic eruptions, eventually it's all going to go off. But now I surmise that a lot of those cosmic rays and secondary showering particles, the muons, it's not just coming in through the magnetic cusp, but as the planet rotates and faces into the sun side solar winds, because our protective magnetic field is destabilizing so much and weakening so much. And the weaker it gets, I think the faster the magnetic excursion. Anyway, that's my lesson for today. Arnold, did you fall asleep back there in the back of the class? That's it for now, folks.